Hi folks. Today we're going to take a look at trig equations 9, operations that occur on the angle in trig equations. As always, there are downloadable notes in the video description below, as well as some practice problems for afterward. So far we've always had equations of the form sine x equals a half, or cos x equals root 3 over 2, or tan x equals something. In these cases, x is really an angle, and we're trying to find the values of that angle that satisfy the equation. But that angle can also be operated upon within the trig statement. So here's an example of one. Sine of a half x equals a half. That changes our angle up, and it leads to an extra step at the end of our process. The good news is, if we can deal with these types of equations, then we have a very good grounding in the basics of solving trig equations. Here's the big idea. Operations that are inside the trig ratio, like this half times an x, brackets are assumed, they're dealt with after we find our angles in standard position. So let's just go ahead and solve this one for all x. Sine of a half x equals a half, right here. Okay, we need to start it off the exact same way. The trig ratio has been isolated, so it's sine equals something. So theta ref, we've done this a whole bunch of times with sine half by now, is 30 degrees, or let's go pi over 6. Let's do it in radians. We're getting pretty good at radians at this point. Okay, that's a positive sign, so we're talking about quadrants 1 and 2. Let's go ahead and sketch. That would be pi over 6 in the first quadrant and pi over 6 in the second quadrant. Okay, now we need to write our answers. We'd have pi over 6 plus 2 pi n for all x. And we'd also have, this other one would be pi minus pi over 6. That's 5 pi over 6 plus 2 pi n. Here's what's different. Normally we would say x equals that. But now, since what was inside was a half x, we just take that and say a half x equals pi over 6 plus 2 pi n. And a half x equals 5 pi over 6 plus 2 pi n. If it had been x plus 7, we'd put x plus 7 equals. If it had been 3x, we'd put 3x equals, and so on. We still have the job of isolating x, but it's pretty easy. If we want to get x on its own here, we have a half x, so we just times the whole equation by 2, both sides. Same thing over here. We multiply both sides by 2. Okay, so that's not squared. It's 2 times and 2 times. That would give us x equals, that would be 2 pi over 6 plus 4 pi n. Over here, we'd have x equals 10 pi over 6 plus 4 pi n. And of course, we'd reduce our fractions. So this is really pi over 3 plus 4 pi n. And this is really 5 pi over 3 plus 4 pi n. And n is an integer. So notice how that half x, it really changed the period, and it changed the angles. So instead of having plus 2 pi n at the end now, we have plus 4 pi n. But all we did is set it up so that whatever was beside the x is still part of the equation, and then we isolate x. Okay, so this would be our final answer. Let's try another one. Cos x, I don't know if you can see that. Let's make it a little bigger. Cos x plus pi over 4 equals negative root 2 over 2 from 0 to 3 pi. Ooh. Start the exact same way. find your reference angle. It's pi over 4. Decide on your quadrants. Cosine is negative over here and over here. Let's sketch. So that means we've got pi over 4 right here. And we've got pi over 4 right here. Okay, if I were to write these in standard position, this one here would be pi minus a pi over 4, or 3 pi over 4. And the general solution would have plus 2 pi n. And if I were to do this one, it would be pi plus pi over 4, or 5 pi over 4, plus 2 pi n. But again, it's not x equals. It's whatever was happening to the angle. So this will be x plus pi over 4 equals. This will be x plus pi over 4 equals. Now, our only job here is to isolate x. So what will I do? I'll subtract pi over 4 from both sides. Same thing over here. Subtract pi over 4 from both sides. Okay, that gives me x equals, well, this will be 2 pi over 4 plus 2 pi n. Sometimes people ask, well, why don't you subtract 2 pi, or pi over 4 from the 2 pi? They're not like terms, okay? One had an n on it, one was just a constant. Over here, this will give us 4 pi over 4 plus 2 pi n. Okay, and let's just reduce those fractions. X equals pi over 2 plus 2 pi n. And this one will be equal to pi plus 2 pi n. Now notice in this case we had a specific domain. We had from 0 to 3 pi. So we've got our general solutions. What we need to do in order to find all the solutions within that domain is to throw in some n values. So n was an integer. So sub in some n values. Okay, and we'll start with 0. If I put 0 in here, we'd just get pi over 2. Is that within the domain? Absolutely. That's between 0 and 3 pi. If I put 0 into this one, well, I just get pi. If I put negative numbers into either of those, then we'd have stuff that was lower than 0. So negative numbers are going to be no good. What if I put in 1? So this was n equals 0. This was an n equals 0. If I put n equals 1 into this one, that would be pi over 2 plus 2 pi, or 5 pi over 2. Yep, that's within the domain. If I put n equals 1 into this one, that would be pi plus 2 pi. Is 3 pi. And then clearly if I put n equals 2, I'm going to be beyond this 3 pi domain. Okay, so I could try it. Oh, n equals 2 into this one over here. That would give me 9 pi over 2. Whoa, way too big. Bigger than 3 pi, no good. So these are the only ones that work. We'd say x equals those values. We'll do one last one where it's got a couple of things happening in it. We've got root 2 sine equals pi over 15x. And it's for a domain from negative 30 to 60, which seems initially like it's going to have a bajillion solutions. Let's check out what happens. First of all, this doesn't have sine isolated. So we're going to divide by root 2. We'll get sine of pi over 15x equals 1 over root 2. Okay, and you might say, whoa, 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 you just divided something that was going on before you found the reference angle. Yeah, but I divided something that was on the outside of the trig expression. I can't do anything about that pi over 15 yet. It's on the inside of the angle. So now that I've got sine isolated, I go and find my reference angle, do all my regular stuff. Theta ref is pi over 4. It's positive. So sine is positive in these quadrants. I'm going to sketch it. Okay, that'll give me answers of pi over 4 plus 2 pi n. And the other one would be 3 pi over 4 plus 2 pi n. Okay. But it's not x equals. It's whatever is in here. So it'll be pi over 15x. Okay. Pi over 15x. I don't really like the fraction beside the x, so I'm going to multiply everything by 15 on both sides of the equation. So that'll give me pi x equals 15 pi over 4 plus 30 pi n. On the other side, I'll end up with pi x equals 15 times 3 is 45 pi over 4 plus 30 pi n. Okay, now I want to get x on its own, so I'll divide by pi. And you can see every term has a pi in it, so this will be easy. Divide by pi. That'll get x on its own. X is 15 over 4 plus 30n. X is 45 over 4 plus 30n. The pi is just divided out. Or if you prefer in decimals, 3.75 plus 30n and 11.25 plus 30n. Okay, so you can work either in decimals or in fractions there. Okay, last thing is for us to make this work with the given domain. So negative 30 to 60. I'm going to sub in n values. And I just like to write what the n values are so I can keep track of them. So if n is 0, well, that first one's going to be 3.75. The n is 0 is not really part of my solution. It's just part of me keeping track of what's going on. This one will be 11.25. All right, let's see what happens if n is 1. Well, this one will turn into 3.75 plus 30, or 33.75. This one over here will turn into 11.25 plus 30, which is 41.25. Okay, so that's n equals 1. We could try n equals 2. That would be 3.75 over here, plus 30 times 2 would be 63.75. And right away you can see the problem. We've gone outside of our domain. Our domain was only up to 60. So this is no good. We did forget some of the negatives, though. Let's try some of the negative values. So if I put negative 1 in this one over here, that's going to turn into 11.25 minus 30, which would be negative 18.75. And if I put in n equals negative 1 into this one over here, then that'll give me 3.75 minus 30, or negative 26.25. Those are all of the solutions that work within the domain. You can see if we go further than negative 1 to the left, then we're going to end up lower than negative 30. So since the domain was negative 30 to 60, all of these values work. Okay. And we're just going to call them the solutions. So if I wanted to write a final answer, I'd say x is the set of negative 26.25, negative 18.75, 3.75. Got to go on to another row here. 11.25, 33.75, and 41.25. Graphically, this would be really straightforward. Here we have to sub in some n values. There are practice problems that go along with this. If you're able to put those together, then as I say, you have a very good grounding in the basics of dealing with trigonometric equations. Thanks for watching.